This video is about how to teach children to do math in their heads, mental math. And this is the first step in teaching them that. Now what you need is an egg carton with 2 of the little holes cut out. And then you need 9 eggs of one color and 9 of another color. If you can't do that, then varying colors is fine. It just makes it easier to see if you have 2 different colors. So, to start off with, children should have their facts to 10 memorized before you do this. If they don't, you can still do this activity, but it just makes it a lot easier if they have them memorized. Now, they should easily be able to see that a row of 5 and 1 is 6. Humans can visualize, without counting, up to 5. And so they won't have to count these. They should know that this is 5 and 1 more is 6. And if they see 5 and 3 more, they'll know it's 8. And they should know that 5 and 5 is 10. So once you have that established, what you can do is begin with something like this. The 9s are the easiest to start with, so we'll start with 9 plus 2. So first you put 9 eggs in the carton, and you will have 2 off to the side. So here we have 9, and we are going to add 2. So what we say is 9 wants to be 10. What does it need if it's going to be 10? It needs 1 more. So let's take 1 from the 2, and we'll give it to the 9. So now instead of 2 down here, we have only 1. So we have 10 and 1. The answer is 11. Next one, we'll do 9 plus 5. So we need 5 eggs to the side. We have 9 plus 5. 9 wants to be 10. What does it need? It needs 1 more. Let's take 1 from the 5 and give it to the 9. All right, so now we have 10 and 4. So the answer is 14. Next, 8 plus 4. So we have 8 eggs and 4 eggs. 8 wants to be 10. It needs 2. Let's take 2 from the 4 and give it to the 8. And now we have 2 left over. So our answer is 10 and 2, which is 12. 8 plus 8. All right. So we have 8 eggs in our container and 8 out. 8 wants to be 10. What does it need? It needs 2. Let's take 2 from the other 8 and, and give it to this 8. And now we are left with 6 over here. So we have 10 and 6. The answer is 16. Now you can keep doing that, but there are other ways to do this as well. You can use a simple index card that you have divided into a 10 frame, we call it, just down the middle, and divide it so you have 5 on each side, because again, our minds can visualize 5, but not more than that. We have to count once we get to more than that. So we have 5 here, and if we have 1 more, we know that's 6, because 5 and 1 is 6. Okay, and then we'll have some other little counters here. So let's try 7 plus 6. So first we need 7 reds, and we're going to have 6 blue. And how many does 7 need if it wants to be 10? It needs 3. So let's take 3 from the 6 and give it over to the 7. So now we are left with 3 over here. And the answer is 10 and 3, which is 13. All right, we'll try 6 plus 5. We need 6 reds, 5 blue. 6 wants to be 10. It needs 4 more. So let's take 4 away from the 5 and give it to the 6 so it can be 10. And we're left with 1 remaining. So our answer is 10 and 1, which is 11. All right, next one, 5 plus 8. Now, when you get to ones like this where you have a smaller number on this side, a lot of times it's just easier to think of it as 8 plus 5 because addition is commutative. You can switch these numbers and it is still the same answer. So instead of 5 plus 8, we're going to think of this as 8 plus 5. And we will have our 5 blue and our 8 red. 8 wants to be 10. How many more does it need? It needs 2. So let's take 2 from the 5 and give it to the 8. All right, we gave that over, so now we have 10 and 3. The answer is 13. Another helpful resource is this abacus. It's called the AL abacus, and it comes from the Right Start math curriculum. The reason it's so nice is because you have 5 colors here and then 5 colors here. So you do not have to count to figure out if this is 8 or not. You know that 5 and 3 is 8. The mind can visualize up to 5, remember that. So once we get to more than that, we have to count. But if we switch colors, we won't have to count because we know 5 and 1 more is 6. So let's try some of these. 9 plus 2, 9 and 2. This is what we want to add together. 9 wants to be 10. How many more does it need? It needs 1 more. So let's take 1 from the 2 and give it to the 9. Bye-bye. Hello. Now we have 10 and 1. 9 and 5. All right. There's 9. There's 5. 9 wants to be 10. How many does it need? It needs 1. Let's take 1 away from the 5 and give it to the 9. Now we have 10 and 4. 14. 8 plus 4. There's 8 and 4. All right, 8 wants to be 10. How many does it need? It needs 2. So let's take 2 from the 4 and give it to the 8. Now we have 10 and 2. 8 plus 8. All right, 8 plus 8. 8 wants to be 10. How many does it need? It needs 2. Let's take 2 from this 8 and give it to that 8. And we have 10 plus 6, which is 16. All right, here's how we do this with Cuisenaire odds. 9 plus 2. Get out a 9, get out a 2. 9 wants to be 10. How many more does it need? It needs 1. So we get a 1 and another 1 so that we can trade that 2 away. Let's give 1 to the 9. So now we have 10 and 1. Our answer is 11. 9 plus 5. 9 wants to be 10. How many does it need? It needs 1. So let's trade that 5 for a 1 and a 4 so that we can give 1 to the 9. And now we have 10 and 4. Our answer is 14. 8 plus 4. 8 wants to be 10. What does it need? It needs 2. So let's trade the 4 for a 2 and a 2. That way we can give 2 to the 8 to make it a 10. And we have 10 and 2. Now it's very, very important that children have their number bonds for 10 memorized. 2 and 8, 6 and 4, 5 and 5, 9 and 1. And that will make this so much easier. All right, 8 plus 8. 8 wants to be 10. How many does it need? It needs 2. So let's trade the other 8 for a 2 and a 6 so that we can give 2 to this 8, and we have 10 and 6. Some children might find it helpful to have a 10 to measure up against that, just to be absolutely sure that it's 10. But like I said before, they should have these facts already memorized so that they don't have to do that. 7 plus 6. 7 wants to be 10. How many does it need? It needs 3. So let's trade our 6 for a 3 and a 3 so that we can give one of those 3's to the 7 to make it equal to 10. Now we have 10 and 3. The answer is 13. 6 plus 5. 6 wants to be 10. What does it need? It needs 4. So let's trade that 5 for a 4 and a 1 so that we can bring this 4 over here and give it to the 6. And now we have 10 and 1. The answer is 11. Don't make them memorize the addition and subtraction facts to 20. They should memorize the facts to 10, and then once they have those, they can easily learn how to figure out the facts to 20 by making a 10. It's much better to have children do it this way because they are using their frontal lobes, they are gaining number sense, and they are not just using rote memory to get these facts in their minds.